Hey guys, welcome to the webinar for Continuous Integration with GitLab, presented by me, Andrew Farley. Let's get started. Who am I? I'm Farley, a senior DevOps engineer and consultant for OlinData. I have experience working with high scalability systems both in bare metal and in the cloud for the last 12 years. I have founded a handful of my own startups and been consulting for a wide range of startups in the Bay Area and around the world. I'm passionate about AWS, cloud services, automation, monitoring, and open source software. In today's webinar, I'm going to explain and show you what continuous integration is, why you should consider adopting it, and give some examples of what it could be used for. Then I'll follow up with a brief demo at the end. Last, I'd ask that you please hold your questions until the end of the talk. I'll leave some time to answer any questions you might have. So, continuous integration, or CI, is the practice of regularly checking that your code will be able to integrate with other people's code. Similar to using source code management, CI is not necessarily something that's required, but when implemented well, CI can help eliminate code quality problems and bugs from occurring or reoccurring. CI doesn't just mean that you can successfully merge your code. It can also mean that your code compiles for compiled languages, or passes a syntax check for interpreted languages. It can mean that your code passes some minimum performance metrics, or can help enforce coding standards. It can also be used to automatically generate code-based documentation. It can even be used to automatically roll out the newest version of your website or API. Really, anything you can think of that you'd like your code to automatically do upon publishing it falls under the blanket of CI. In practice, CI tasks are initiated after publishing your code to a remote source control management server, some of which, like GitHub or SourceForge, you may be quite familiar with. Others, like GitLab, are somewhat new but gaining popularity fast. These source control systems can initiate continuous integration processes. There are various cloud-based CI providers that integrate quite well, including, but not limited to, Circle CI and Travis CI. And if you'd like to host your own CI, there are numerous products for this, including Jenkins and Hudson. In this demo and presentation, we're focusing on using GitLab's integrated continuous integration system. GitLab is basically an open source version of GitHub. It has an interface that feels familiar and is very usable and highly extensible. GitLab even has an enterprise edition which offers better service integration, more robust webhooks, a built-in wiki feature for users to collaborate on, and more. GitLab is ideal for customers which for legal reasons cannot host their own code on GitHub or some other SaaS-based source code management service, or that can't afford to use the paid GitHub service for private repositories. In a well-designed continuous integration workflow, you have one or many developer teams which develop and commit code. When they push code to the source control repository, it initiates CI hooks, which can kick off one or many parallel or serial tasks, including things like testing if the code builds properly. If any of the integration tests fail, using one or many notification mechanisms, such as sending an email or sending a message to a team on Slack or HipChat, any failures that the developer caused should then be fixed by that developer, which then completes the typical CI workflow lifecycle, until eventually the code passes all the tests and it's ready for deployment to live systems. Instead of starting with or already having CI and unit tests and integration tests, you can start with any existing code base and begin to slowly adopt CI. Assumably, you already have a bug reporting pipeline. Instead of your developers just fixing a bug, have them also write a test once they fix a bug in some testing framework that tests to ensure that that bug is fixed. These tests, if written well, guarantee that that specific bug will never pop up again in the future. If you or any developers have probably worked on a system, you probably had this happen to you before. It'd be nice to not have to fix a bug more than once, huh? Why continuous integration? Really, in the current technical landscape, it doesn't really make sense to not use source code management systems. And in my opinion, similarly, it also doesn't make sense to not use at least some form of continuous integration. As your company or code base grows, you can in turn grow the complexity of your continuous integrations. Generally, CI helps guarantee the quality and integrity of the code and helps simplify your life, both as a developer and as a sysadmin. So here's a few brief snapshots of GitLab's continuous integration system and what the output might look like. In this first slide, we're ensuring that the code compiles and executes properly. In this image, you'll see basically a unit test kicking off that attempts to build a very simple Hello World application and then verifies that it executes properly. We'll actually use this in our demo later, so I'll show you a little bit more about this. In the second slide, we're ensuring that the code follows some code style guidelines or some compliance rules. You'll actually see in this example that I've on purpose made it fail so you can see what a failure looks like. This is actually executing Rubocop, which is just a Ruby syntax style handler. And actually, if you notice, they're technically not errors, they're just warnings, but the way that we've configured it, it actually considers this a failure. This next integration slide shows code passing a series of unit tests and ensuring a minimum performance standard. In this example, we're using Rake to execute a series of tests. You'll see there down at the end, it's executed about 112 assertions in 27 runs with no failures, no errors, and no skips. So this build has succeeded. As I mentioned earlier, GitLab comes with integrated continuous integration support. But one thing that's missing out of the box that you'll need to do before you can run a CI job is set up a runner. A runner is basically a daemon that runs on a server somewhere to execute your CI jobs. You could run it on the same server that your GitLab server is on, or you could spin up one or many cheap cloud-based server for the task. Putting this onto a cloud provider can also give you room to grow if you plan to host hundreds or thousands of code bases or have hundreds of users concurrently working on your systems. You can scale out continuous integration horizontally indefinitely. For this slide, I've included the URL to the runner, or you can just Google GitLab Runner for more information. It's quite easy to do. There are multiple executors that a runner can run in. The fastest is shell, since it basically just executes the code it checks out directly in that shell environment. But this is also the least safe. I personally recommend to use the Docker executor. For more details about this, please look at the GitLab Runner URL, or feel free to ask me some questions at the end. GitLab CI is quite easy to implement. It's similar to other cloud-based continuous integration softwares in that you basically commit a file in the root of the codebase which defines the various tests and integrations to be executed. The file is .gitlab-ci.yml. If using Docker, you can actually define which Docker image to use and which services and or softwares then to also have available on the Docker image before executing your tests. And now, on to the demo. So first here, I've created a few sample projects. This first one is going to be a very simple project here written in C++. You'll actually see, if you just Google Hello World, you'll see I've created a simple Hello World program written in C++. Now, using CI, we want to verify that this program compiles. So here is the .gitlab-ci.yml file. You can check it out. And this is the same image you might have seen in the demo earlier. And basically, it shows right there, the first line, we're using a Docker image, Ubuntu. Then before it executes, this is actually the test down here, but before it executes it, we want to make sure that this image has the necessary tools to compile. So we're going to install GCC. And then right here, actually, we're defining what we want it to run. So the script we're running is actually, G++, hello world, putting the output at hello world. And then this next command is actually, typically you do something like running a unit test software. We've actually just written a shell script within our project to verify that this program was compiled successfully. So we can go check out what that looks like. Here's our little verify script. You'll see basically it just starts up and prints some information. It tries to execute the hello world executable, which you'll notice doesn't exist here because it's going to be compiled. It checks to ensure that the return value is okay, and then it checks to ensure that the output of the script is okay. Now let's go kick off the build. This is a previous build, but let's kick it off again. Retry. So here's the build actually executing. What it does is it just schedules a job to be run. The runners on another server actually checks to see if there's a job waiting to happen. It goes and picks up this job. It grabs the Docker image, starts up Docker. It grabs the code base right here. It does the pre-commands, which we specified first to apt-get update. And you'll see it's taking a minute here. It's actually doing it as we speak. Then it goes and installs GCC as we've asked it to. Which takes a minute. Be patient. Almost done here. Yeah, and then there's the last thing it does, which you might have also heard it ding at me, is it actually goes and runs G++ to compile the program, hello world. It runs the verify script, which you'll see the same output referenced from my script earlier. It starts up, it checks to ensure the return value is okay, checks to ensure the output's okay. And then the last thing it does, which is a really neat feature of GitLab, is it actually allows you to save things from within your CI runs. In this case, we asked it to save, which let me show you. We asked it to save everything. We asked it to save the hello world program. So how this works is you can actually, right here, I can click download and download this. So if you built, for example, your entire website, you built the output of your website, the HTML and the CSS, you can actually just click download and download a copy of everything that it's generated for you. So this is a really simple example. I'd like to show you what it looks like when it fails. I'll go and modify the hello world program really quick, and I'll just do it here in place. I don't need to use the command line or anything. Invalid. Making test fail. Click commit. And you'll see another thing that happens here, which is something I mentioned in my presentation earlier, which is that it's actually notifying me, and I think that this is an important and integral part of using continuous integration, is actually being notified via some mechanism. If your team uses some type of chat, our team, or we tend to use Mattermost and HipChat mostly. If you use any of these systems, you can actually see, you integrate the GitLab with these softwares, and you can actually see when things happen. So here I'm getting notified that I pushed some code, and then in a few minutes you'll actually see that the build is failed. We'll see. Let's reload this. Build is running right now. So it's rerunning the test right now. And it just failed, and it also let us know here on our team chat room that it's failed. See, it's still compiled the program, and it's tried to run the program, but then the output's different. So it basically didn't verify. So if this was basically a detailed unit test, this unit test would have failed, and it would have notified us, and then the developer is then responsible for going back through and fixing the program and making it succeed again, like it did earlier. So this is a very simple example. Now I'm going to do a little bit more detailed example using Ruby. So here's a simple Ruby project I've created. It's basically just a bare bones skeleton project. Here's the files. You might be, if you're familiar with Ruby, you might be familiar with, kind of the folder structure here. But basically, we'll look at the GitLab CI.yml file to see what we've defined here, and I'll kind of walk through it with you. Here, the first thing we're doing is defining the image. Actually, I've commented this out temporarily. I'll put that back in place.
And then the second thing here, you can actually specify if your program requires services, which is a Docker feature such as MySQL, Redis, or other various services that are pretty typical in using a software. You can specify them right here, and then when the Docker image is spun up, it'll make sure to also go and include those services, besides having to also do things like using the scripts here to do apt-get, install MySQL, and everything. This is much easier to get some of those services up and running. You can actually define custom build variables, and this is great if your build path is extremely complicated. You can set the Rails environment. You can do all kinds of things right here. That's basically your environment variables are going to get passed into your scripts, or they can also be referenced in your scripts, which you'll see right here, basically with a $sign. Stages is another neat feature, which a few different CI softwares have something similar to this, which basically lets you define the stages at which your build is going to happen. That every stage of the build will only happen if the previous stage succeeds, or unless you set a case where you only want it to happen if the previous fails. And I'll show you how this failure one below actually works. Right here, so typically in a build process, this is a sample of what you might use in a typical Ruby process. In a typical Ruby project, you would actually run rake assets precompile. Assets precompile is a really typical thing in the Ruby world, which actually takes your HTML and takes your CSS and builds it together. So I've included this as a sample of what you might put in a real Ruby project, but for our purposes, what we're going to do is we're just going to do a simple copy. So I'm going to make an output folder. I'm going to make the assets folder. So I'm going to kind of make my own build system here, and I'm just going to copy the data from our data folder into our assets folder. So in this project, the assets folder doesn't actually exist. If you look back here in files, there is no assets folder right now. So this is before the build, of course. So that's all that this is going to do, and then it's going to do this other thing right here, which is it's going to save the artifact it's going to save the output of what it's actually generated, or in this case, just copy to the assets folder. Then here we're going to actually run the test, and this is in the next stage, in the test stage, and we're going to execute two different tests. We're going to execute a rake test, and then we're also going to execute a syntax and basic grammatical check using a Ruby software called Rubocop. And then the next thing we're going to specify here is the build, the dependency, which is that when you define this is a newer feature of GitLab actually. It'll copy the artifacts from a previous build instance into the next build instance. So it's actually going to copy the output from the assets folder into this separate Docker image in this separate build run. So this is a neat way to carry over compiled assets from one stage to another. Then this right here introduces a new feature, or a feature I haven't yet explained to you, which is the on failure. So typically each of these stages only occurs, the next stage only occurs when all the previous ones succeed. Well, there's a special handler you can have here, which is when on failure. When you set this, then this only executes if any of the previous steps have failed. And it doesn't have to be all of them, but if any of them have failed, then this will execute. So this is a good way in here you can actually do custom things like integrations or rollback, or you can do cleaning up of your build process, or anything like that, or notification, letting someone know that your build's failed and stuff. Then the last thing we'll do is we'll pretend, in a larger maybe production system, maybe especially if you're on the master or production branch, well, if all the tests succeeded, you might actually want to deploy. This is a little bit of a demo. I'm not actually going to deploy anything here, but you could use tools like Capistrano, or use the AWS tools if you're on the cloud, to actually push this code to a live server, push the compiled. And since we have the dependencies built here, it's going to copy those compiled artifacts. You can actually use those assets to then copy it, or even FTP it to like your live server to get it to go live. One other thing I'd like to explain here is this key right here, this variable deploy key here, isn't defined here in variables. So if you don't want your developers to have access to like your private AWS key, or your SSH key to be able to deploy, you can actually set private variables within the project. And I'll show you that really quickly where that is. Here in settings, in variables. So this is you have to be an admin of the project, and this is a environment variable that effectively we've set that users, like your developers typically won't have access to, that just a sysadmin would put this in place, and then you'd be able to, script it within the YML file to be able to then deploy the code to your live servers and stuff. So let's kick off a run. Let's kick off a build with this. We're going to do this by modifying a file in this one. Go to project, files. Let's just edit this in place. Kick off build. So we'll pretend this is modifying, someone's actually modifying the code somewhere. You'll notice I got notified that I pushed to commit, and you'll see the builds here on the left. It says build 1. It's actually doing the build. Right now, I'm introducing you to a newer feature. It's actually telling you which stage. We in that GitLab CI.yml file, we defined multiple stages. So here's actually the build stage. It's processing as we speak. You can click on it and we can see what it's doing. It's starting up the Docker image. It's grabbing the code base. It's running bundle install, which is basically it's the way you install libraries from within Ruby. Then it's doing our fake build process, which we defined and I explained earlier. It's creating the assets folder, and it's copying the data from one to another, which you would typically use something else to actually compile, like the pre-compile assets. Then it's saving those artifacts into GitLab itself, and then it's done. You'll actually see here at the top, then another tab shows up, which means it's actually executing the next test, which actually, while I was talking, it succeeded doing. It did all the previous tasks, and then it ran the tests. So it ran bundle exec rake test, and then it ran bundle exec rubocop, which currently everything succeeds. This has a really simple test just to make sure everything works, and then this is a syntax check. It inspected 4 files with no offenses. And the last thing it did is we did a mock deploy, which did everything else. And then the last thing it did is it ran this script to actually just demonstrate how secure variables work within GitLab. Typically you wouldn't echo them, but you would just use them for actually SSHing or getting access to automatically deploying it to other systems. But here we're just listing the contents so I can show you how dependencies work. So in the data folder, I just have an index.html file. Here I've just listed what's in there, and this has actually been copied all the way from the first build phase, the first build step, all the way back here. That was built right here, because the index it doesn't list the file here, but the index was actually copied from in here, and I can show you that index is in data right here. Yep. Great. Well, that really concludes the demo. Both of those sample projects I've actually made open source and made available to you guys. You can actually check them out at our GitHub, sample GitLab CI Ruby project and sample GitLab CI C++ project. If you'd like to check them out, I'll open one up so you can see. Oh, my internet's not working. All right, well, that really concludes the demo. If anybody has any questions or comments, please feel free to put them in here right now. Raise your hand and ask a question. Sure. Do we have any questions? Okay. So Nap Ramirez asks, is there a way to visualize the steps of the CI build No, currently there isn't. That's a really great question though, and that's actually something I've had somebody ask in the past before. So no, there really isn't a way to visualize the steps. Though technically you could actually do this some ways yourself. Since that you can just have scripts there that do really whatever you want. You can actually have it push stuff into like a CSV, or even call an API, some external service. They can then do a little graph that actually visualizes the success or failure of each of the various steps. So that's a really great question, though. I like it. Is there any other questions? And Nat Ramirez also asks, is it usual to build Docker images in GitLab CI? So I kind of touched on it earlier. So if you want to use Docker, I personally recommend it, because then you can run your CI on the same server that your GitLab server is on, and you have isolation between your actual server and what the tests are running. Because technically your tests could go and remove files from your OS and kind of poison the entire environment. So you don't build Docker images per se. You're more of a consumer. You actually it downloads them here automatically. It pulls it. If it doesn't have it, it goes and pulls a Docker image. So it does kind of it doesn't. You don't actually build your own Docker images. You just kind of build off of existing Docker images typically, and hopefully you have your environment is relatively simple. Though if you have a very complicated environment that has a lot of dependencies, building a Docker image might be overly complicated. So what I actually like to do, I recommended it, I mentioned it earlier, is I like to spin up a server on a cloud provider like AWS or DigitalOcean, and then prepare it with everything that you need, that your software needs to be able to run tests. So you can actually install all the software necessary, and then here I'll go to there's a yeah. So you don't typically build Docker images, is kind of what to answer your question there, Nap. So Om Prakash Singh asks, how can we integrate Jenkins with GitLab? And can that be integrated similarly as GitLab CI? And can the results be seen at the GitLab console? So Jenkins really is another CI system. You could integrate Jenkins with GitLab because GitLab supports using webhooks, similar to using GitHub. But in order to enable the webhooks on push, you actually have to own the enterprise edition of GitLab. And then what it can do is GitLab can push a webhook to Jenkins and kick off the CI in Jenkins. And then the second part of your question is, can that be integrated into the GitLab? Can that be integrated into the GitLab console? No, it can't. It's kind of an external webhook, as far as I know. I've never actually done the integration to Jenkins, but I would guess right away that no, it's not going to do that, because GitLab offers its own CI system. I honestly don't know why they would go and support an external CI system when they really have quite a robust built-in CI system there. So thanks for that question. Does anybody else have any questions? How can the artifact archive be configured? Be configured. Can you clarify what you mean by be configured, Nap? You want it located in a different location. I'm still not quite sure what you're asking, but here, I'll enable the presentation again and go look at the, I'll show you the files here. And, oh yeah, such as pushing it offsite. So actually, what you're asking for is to be pushing it. That's basically what you want. What you're looking for is to instead use a deploy feature. So the archive feature really is for the artifacts feature. Sorry, really is for putting stuff into GitLab so that you can download, or for passing data to another build step. So that's what the artifacts feature really is for. But what you're asking for is for pushing it offsite. Basically, it's kind of like a deploy. And so for that, you actually want to use an API call here or whatever scripts are necessary to push it to Nexus, push it to S3, push it to whatever other external technologies using, preferably like a deploy key or a username and password or whatever. You'd actually do that here with as part of a build step. It wouldn't be an artifact feature. Now you can use artifacts in order to have it from the build copied into your deploy step. You'd make this like deploy underscore nexus, and then you'd actually execute whatever necessary to actually push it into whatever external integration software you'd like to back up that with. I hope that answered your question, Nap. Oh yeah, and that's a great question. Om Prakash Singh asks, can we keep the GitLab and set up CI on 2 different nodes, in this case without Docker? Yeah, actually, this is that's something I kind of mentioned. You don't have to use Docker, but another thing that's really awesome is the runners. I'm not sure I shouldn't open that one here. Runners. So you can have multiple runners down here. And each of these runners, typically the runners are public, but you can actually have public and private runners, and you can actually lock specific runners to a specific project. So you can actually have your runners on multiple servers. I mentioned it briefly earlier, and I kind of went very fast, but the GitLab server is just one server typically. Although you can actually set it up with Enterprise Edition, you can set it up in an HA configuration, in a high availability configuration with 2 or more servers. But the runners can scale horizontally indefinitely. Here in this example here, I have two runners, but I could easily have 10 runners on 10 different servers, and they can all be basically polling and waiting for jobs to execute. So yeah, you can have them on any servers you want. You can have them in distant locations. Actually, in our example here, we have a GitLab server and a runner locally, and then we also have a separate runner which is remote. It's actually run on a cloud-based server. That way we can kind of scale that up if we need to. And all I have to do is clone the server. I have an AWS image, and all I have to do is hit spin up a new image of this. Technically, you could also tie this into auto scaling. You could detect that the load gets too high on one server, scale it up to 2 servers, scale it up to 5 servers and stuff. So you can actually automatically auto scale up your runners as well. So that's some really neat stuff you can do. I hope that answered your question, Om. Any more questions? I'll keep it open for a few more minutes, and if nobody has any questions, I'll end this chat. I hope this was an educational, presentation for you guys. I hope you got a little bit from this, and I hope that you consider using CI very soon and or in the future. Om Prakash Singh asks, can I use GitLab CI with satellite? I don't actually know what satellite is, so I don't really have an answer for you. What build metrics are available in GitLab? Oh, so Nap Ramirez asks, what build metrics are available in GitLab CI? I'm not sure what you mean by build metrics. Basically, the builds are builds are really defined by you. As far as metrics, as I think you're asking how, like maybe how long it runs, the durations it takes. Really, that's the kind of only metrics that you have here, is the ability to see how long the builds actually take. And that's about it. But in the CE edition, in the non-enterprise edition, you can't actually pull this data. In the enterprise edition, you can actually pull this data via the API. So you can actually pull this data into like an external monitoring system if you'd like, like Zabbix or Isinga or Nagios or something. So that's the only metric that really I can think of that are available, especially externally. But besides that, you can actually in your GitLab YML file, GitLab CI YML file, you can define your own. You can actually in one of those examples I showed in the demo earlier, there is. And this is a client of ours. It actually does some timing here in the middle. It shows it takes X amount of time to generate. You can actually take those metrics from within your build process and then push them off to an external monitoring system or metrics gathering system, such as Elasticsearch or some other type of logging or monitoring system. So built in doesn't have much metrics, but really you have the freedom to then go and implement whatever you want on top of it. So. Hope that answered your question, Nap. Any more questions? All right. Well, I think, oh, yeah. Okay, all right. I think there's no more questions. So thank you guys for attending this webinar. It was my pleasure to, show you guys something I'm really passionate about. And I, hope that you guys, possibly get interested and are passionate about it as well. If you guys have any questions, where's the presentation play? If you guys have any questions, feel free to email me or jump on our website if you'd like to contact us as a company. And yeah, thank you very much for attending. Take care.